So welcome everyone. My name is Jimmy. You can find me on Twitter at @jbogard. Don't forget to use that @ tag. It helps feed my ego to see me on the top of the leaderboard there. You can also find everything I do on GitHub, so github.com/jbogard. Projects there and also presentations as well. I blog on jimmybogard.com. I also used to blog on another website on Los Techies, so you may have read a few of my blogs over the years on there. Some of the other projects that actually be talking about today because it's relative to our convention discussion over on the right. So AutoMapper, Mediator, and then one we'll talk about today too is the HTML tags one. So yeah, this talk is about blowing up the bike shed with conventions, and I'll explain what all that means as we go through the title here, or go through the talk here. So the idea of bike shedding came from this Parkinson's law of triviality. There's another few laws out there that aren't as fun as this one. So not the law about every online discussion devolving into something about Nazis or Hitler. That's Godwin's law, not that law. This law, Parkinson's law of triviality, says that humans spend a great deal of time on trivial details while the more important matters are skipped. And this is especially true for us as developers. We spend a lot of time on stupid stuff that doesn't actually matter, stupid stuff that doesn't actually matter to the end value to the client. We spend a lot of time automating our jobs, and that's okay. It's the other stuff that doesn't really provide any value to anyone that we seem to spend a lot of time on. And so this idea, Parkinson's law, originally came from a focus group that a psychologist put together to help design a nuclear power plant. And a nuclear power plant is pretty complicated. There's probably a lot of things here you want to get right. But it's so complicated that no one person can really grasp everything that's going on here. Like, it's probably really important those coolant towers are hooked up okay, and something about those coolant towers and nuclear rod. I actually have no idea how this all works. But it's pretty important to get everything right. But what this group was focusing on when they said, we want you to design and build a nuclear power plant, they didn't focus on the really important matters, things like make sure it doesn't blow up. Instead, they focused on like the little hut in the lower right-hand corner, right down there, which was where people park their bicycles on the way to work. And so they focused all of their time and energy not on designing this, but on designing this, the bike shed. And so this is known as bike shedding, where we spend all of our time and energy on the things that we can grasp, the things that we can understand, the really small things that we can fit in a little box and say, I understand everything that's going around here. But the more important details, the overall architecture of the system, the things that actually matter to the end user and the business, those are the things we don't really talk about because those are harder conversations, harder details to get right. And so we tend to skip over them in favor of the really boring stuff. And so this is known as bike shedding. And a lot of projects I see that are grown over many, many years have a lot of bike shedding going on. And there's a lot of different ways in which we as developers actually do this bike shedding, and we're all guilty of it, even you, and you over there too. You're asleep, so you're okay. Everyone bike sheds a little bit. So what are the things that we see, that we argue about as developers that really don't matter at all to the end value delivered? Things like class names. Have you had meetings where you have to decide a class name? Yes. Class design, member naming, folder structure. Like, do you have to decide between infrastructure and services? Maybe you have two folders like that. Do you have separate projects for those? These are the kind of things that we talk about. Different patterns, of course. We argue about what patterns are the right ones to use. HTML layouts. This is the one where people move things by pixel to make sure they're just exactly right. Different HTML widgets. So what is the best date picker out there? You could probably spend a good 2 days going through all the different date pickers to figure out what is the absolute best one, even though it doesn't really matter. How we do validation, and probably the one I see the most are SQL object names. Anyone have a database with at least 4 different naming conventions? Yes. So you probably have things like tables have plural and not plural names. Some tables have a prefix, TBL, name of the table. Maybe it's TBL underscore and the name of the table as well. It gets more difficult when you get into view and store procedure names. Store procedure names could be SP and SP underscore. Do you have both of those as well? Yes. It seems like every time there's a new tech lead or DBA on the project, they have to make their mark in the system with their opinions about how things should be built. And so it becomes almost like a geological survey. Through time, you can see whose opinion was being enforced at what given point of time throughout this application. And I can see this sort of thing devolve where if I'm a developer new to the project, what is the right way of doing things? Well, there is no enforced right way. I have to go look at the last way of doing things. So I may go in source control, like what was the last pull request accepted? Okay, looks like that was the right folder structure and naming convention. So I'll do it that way because that's the way it should be, because that was just happened to be the last thing that was done. But that doesn't mean it was the right way. It was just the last way of doing things. So these kind of micro decisions where I'm deciding class structure, folder names, all those kind of things that don't really matter to the end user, don't provide value, those are the kind of things I can see derail projects from the developer side. We're spending all of our time on little details that don't actually matter as opposed to actually delivering business value. There's a secret, though, here that is a little painful for us as developers, which is that our opinion actually doesn't matter in the end. Your naming convention opinion, your folder structure opinion, none of that actually provides any business value to the end users, and so ultimately, it doesn't really matter in the end. What I greatly prefer and want to have in the systems I build is consistency over correctness. If things are all the same, even if they're all not my way of doing things, that's more important than having my opinion being put on top of a project. Now, if I'm in a system where the opinionated way of doing things is causing productivity issues, then okay, I can go ahead and have my new way of doing things, but I always have the law of two, which there's no more than two ways of doing things in a system. And there has to be a plan for moving from the old way to the new way. Where I tend to see things tend to go wrong is when a new tech lead comes on, they have their new way of doing things, but they don't ever have a plan of finishing out and getting rid of the old way. So they leave, and then a new tech lead comes in, and then their new way is in there, and so now I have three ways of doing things. And then they get bored and they get tired of having to deal with two ways and another way, and so on and on and on. So I eventually have so many different ways of doing things, there's no consistency in the code base. So for me personally, I don't really care what your naming convention is, what your structure, what your layout is. As long as I adhere to those rules, that's more important than having my own opinion being put in the code base. Now that's all well and good to say we want to enforce, we want to minimize the number of opinions being put into our code base. We want to have a consistency throughout the entire code base. But how do we enforce those kind of opinions across our code base? How do we make sure that everyone does everything the same way? And the way we do this is with conventions. This is how I enforce rules about how to build our applications throughout the entire system. So what are conventions? This is something that was popularized from Ruby on Rails. Ruby on Rails said, instead of us having all this explicit code, we were copying and pasting it over and over again. Instead of us doing things like code generation that worked well once, but there's always something that needed to be changed, instead they said, let's build our application and our framework so that it's designed around these conventions, and the conventions about how software should be built would then be enforced in the entire application framework. So conventions are a set of coding policies that are applied and or enforced across the entire code base. And by making sure that my policies are enforced, I make sure that no new person's opinion, however valid they may be, don't leak into my code base and generally muck things up. So why should I care? I would say for most size projects, this kind of thing doesn't really matter quite as much. But for projects that tend to be long-term, that have to live a number of years, or are of a certain size, then I want to have some sort of consistency enforced in my projects. So a couple of projects that we really found at conventions work well for us. Actually, if anyone was in my talk this morning, these are the same two projects we're talking about. But really for all of our projects that I do at my company, a consulting company, we have convention-based development. And both of these were very large applications. Both of them had hundreds of actions. I think the first project had over 1,000 different controller actions, and a lot of different things I was going to deal with. And what I wanted to make sure that as these projects were developed over many, many years, that the same coding standards that I had on the first few months of the project would be the same coding standards I have on the year 5 of the project with both of these different projects I was on. So unfortunately, the framework we were dealing with, ASP.NET MVC, had 0 conventions that it defined for us. It had really no preferred way of how you build applications. They just said, here are a bunch of tools, and it's entirely up to you how you want to build the system. So we had to figure out what was the right way that we wanted to build applications. And so we looked at a number of different systems out there at the time to see what are ways people were building MVC applications at the time, and what makes most sense for us in the .NET land. At the time, we were looking at a couple other major frameworks on how to build MVC applications, which would be Rails at the time and Python's Django project as well. Both of those projects are built on top of dynamic languages, so it was a little bit tough to translate the monkey punching, wait, no, that's not right, donkey patching, no, whatever it is, and what it meant for us in the statically typed land. So it meant looking at the different things available for us in that application and figuring out what are the right ways that we want to build those systems. Now, unfortunately, the documentation at the time for Microsoft was really, really bad ways of building systems. It was great examples of how not to build systems. For example, this is from the official Microsoft documentation about how you should build a controller action that performs a post and does stuff. And so this is the wrong way of doing things. So this one, for example, it's a post action to create, in this case, a new instructor. And the thing that it would be using to model bind against, that is, what it was using to bind those raw request parameters into an object, was the actual live domain object, the data object that was connected to the ORM behind the scenes. And this can pose a problem. Actually, Ruby on Rails had the same issue a couple years before this, and they solved the issue in the exact same way. So the issue with Ruby on Rails is you can directly expose your active record models, which are things connected straight to the database, as things that we bound directly against request parameters. And so originally, Ruby on Rails would blindly take all those key value pairs of request parameters and apply them to the active record object and then go ahead and save, without any validation that said, these are the parameters that I actually wanted you to bind against at all. And so this vulnerability, which is known as the mass assignment vulnerability, was discovered by a developer. And so the developer opened a GitHub issue that said, hey, you had this security flaw. Someone could just post any parameters they wanted, and as long as they matched some column that existed in that active record object, it would get saved and persisted. I guess the Ruby on Rails team wasn't as timely in their response to the GitHub issue. And so what the developer wound up doing is they learned that Ruby on Rails was the underlying framework, and still is, of GitHub. So they opened a pull request to close the issue, or to patch the issue, using a way of either a list of includes or excludes to say includes these parameters or exclude these parameters. And because they knew that Ruby on Rails was the underlying framework of GitHub, they exploited this vulnerability to make themselves an administrator of the project to accept the pull request to close the issue. So that was kind of a cute way of doing things. The Ruby on Rails team was not exactly excited about that. They wanted them to go through the normal process of opening up an issue and waiting for them to respond. But it's a pretty big issue. If you knew something was built by Ruby on Rails, you can just start guessing on different variables and be able to take control of a system. Things like, oh, this is a user edit screen. Can I make myself an administrator? Can I add roles to myself? Just post those things up, and then you could extend your data in a way that wasn't actually meant to in the system. So the way that the MVC team knew about this and exposed a way for you to close this security hole was to provide this incredibly janky way of having a comma-separated list of string parameters that match to property names on your objects. Now, I don't know about you, but I never get strings that are related to property objects wrong. I always type them correctly, and I certainly never switch letters around or accidentally forget one every time something new shows on the screen. I never do that. I always make sure all my pull requests never have any security flaws. But of course, that's not true. Maybe it's true for me, but of course my team, maybe they don't have that same level of rigor that I do with the things I build. So this is not going to scale. I mean, every time I add a property to the screen, I'm going to have to go back and remember to do something. So in general, in my programming, if I have to remember to do something, I'm going to forget. I'm going to assume I'm going to forget. So I'd rather have a programming paradigm that says, instead of you having to remember to do things, I will design the system in such a way that you cannot forget. And if you forget, it'll just break. So instead of us doing this, where we have this domain object directly being bound with request parameters, and this having to remember this crazy comma-separated list in a string, instead we had a very cunning plan. We'd build these things we called view models, which are essentially DTOs that represented only the properties I would be showing or editing on that screen for that one individual request, not to be shared anywhere else. Now, with this view model, I am binding directly against this for form posts as opposed to my live domain object. So this is already an approved list of all the properties I would bind against. And if I want to have a new edit field on a screen, I would have to have it in this DTO as an explicit new property that was added. And if I forget to put that property on there, my application won't even run or compile. It'll just completely fail. If I remove something from here, then again, my application won't compile or run at all. So by building up these individual view models for every single screen, I can enforce a policy of don't use a domain object for your posted-in models. This is where we had a moment of panic, though, or we as in me. I was a tech lead on this project because I knew that I was going to have hundreds of controllers, hundreds of actions. I didn't think I was going to have 1,000 actions. I probably would have pumped the brakes a little bit earlier if I knew that it's going to be that big. Hundreds of view models, hundreds of views. How would I enforce some kind of commonality between all these different DTOs that were going to be created? And so when we started the project, every single page would have its own DTO, but every single DTO was bespoke, handcrafted, custom built just for that one screen. And so there's no consistency about the naming or anything for any of the DTOs anywhere else. So if on one page I wanted to call something full name, and another page I just called it name, there was nothing that was enforcing any kind of naming conventions between those two. Every single new page, it was up to the developer to invent what that DTO would look like. So I knew I don't want to do this. I don't want to have to enforce all these different conventions for all these different pages. So I took a step back and said, okay, what kind of patterns do we have here across our application? So I looked at both gets and posts because those are the two kind of main things that were going on in my system. I looked at the gets and said, okay, what are the kinds of things I'm doing here? Well, I'm taking some parameter from the outside world, going and getting something from the database, and then I'm doing a projection from that more complex model into a more simplified model. Sometimes it was a sort of a simple projection like we have here. Sometimes it could be more complex. But the big deal was I always had this going on, which was building out a model, projecting information from a more complex model into this individual one. So originally, there was no patterns in place around what this DTO looked like. But there were some things I thought I could enforce. So instead of us, for every single DTO, deciding how every single thing should look, perhaps I can just have some policy being enforced. And if you haven't guessed it, this is where my project AutoMapper came from, was trying to just simply enforce a policy of making the DTO look always a certain way, following a certain set of rules. So what was that policy? Well, first of all, on the new DTO, I would want to make sure that, one, it would automatically map property names that were exactly the same. So just copy over those details exactly. There were sometimes we had calculated fields and calculated properties. So if there's some kind of like get method that did a more complex calculation, I could just map the result of that value of that calculation into a single property based on the name. So just like remove the get, take off the parentheses, have a property, and I'm done. For more complex properties, maybe I'm navigating a set of fields, I would just remove the dots from whatever I was navigating and say, yes, that should be the property name on the destination side. That also meant that I could somewhat handle collisions. I would assume that no one would have like foo_bar.baz versus foo.barbaz. That would just be totally confusing from the object design in the first place. So I tried to have some obvious conventions there that just said, if there's a collision, then maybe throw an exception, but that really shouldn't happen in practice. But just remove the dots, flatten everything down into a single property name, and that will be how I would automatically map from one property to the next. I also wanted to handle the obvious, like lists, arrays, enumerations, primitive values. Just figure all that out. It shouldn't be that big of a deal. And so the result was AutoMapper, in which instead of me explicitly mapping out how that complex domain object maps into this dumb DTO, instead I would say just one line of code, say map that complex object into the DTO via a series of rules that say names must match, remove the dots to flatten things out, things like that. I can even have more complicated sort of mappings as well. So AutoMapper also supports the idea of link projections. So in link projections with AutoMapper, instead of me hydrating the complex domain objects in memory and then mapping that result out, instead what I can do is use link to replace a select projection in link with a projection from AutoMapper. So it builds out a select projection, hands it to the ORM. ORM translates that select projection into SQL, and I go basically straight from SQL to my DTO through an enforced set of policies that say, these are how the property names all must match up. So all those lines of code in my system that were mapping junk from a complex model to a DTO, we were able to just essentially get rid of. Now, there were more complicated cases that we needed to handle specially, but for like 95% of the things that we're doing, we were able to say, map that one thing to the other. So that basically took care of all of our gets. We no longer had any more arguments, those stupid arguments about what the naming convention should look like, how the property should look. All those arguments just went away and said, you know what, we have a tool that enforces a standard, so just use that tool that enforces the standard. If it doesn't work, then things won't map up and your application will break. Call it a day. We also looked, after going through the get side, we looked at the post side. Now on the post side, where I'm writing data back, this is where things became more complicated. If I look at the actual work being done here, I've got some validation junk, loading the thing, and then redirecting at the bottom. The more interesting part here, when I started to compare across different controller actions, it wasn't so common. There was no real policy I could enforce. This is the real interesting part of the application. And in fact, this is the stuff I wanted our developers to really focus on. This is the real work being done in our system. So because we had more behavioral entities, the logic was a lot more complicated, and there were no real patterns that we saw in there. It was always very custom to the work being done. So in this case, we said, you know what, this is the cool part of the system. This is what's interesting to our users. So let's just leave it alone. We won't use any kind of automated mapping tool to try to map back into these complex objects. Which is why for the people that have used AutoMapper, you probably have problems mapping back into things, and that's because I never want it to be an actual use case. It's the part where I'm mapping from complex data objects into a dumb DTO. That was the thing we can enforce a lot of policies on. Now, our team didn't stop here. We saw this is just one pattern we saw emerge across the lifetime of our application. But what other places did we see that we wanted to enforce a set of conventions to remove these stupid arguments that we're having? So there are a number of different conventions we saw out there. Ones that can be ones that could be explicitly enforced, like AutoMapper does through its behaviors, and some other ones what we saw that were more implicitly enforced. So in this case, our implicit conventions, these are ones where the policy doesn't necessarily derive any sort of behavior in our system. So the AutoMapper tool will enforce policies via how it maps. But there's sometimes where there's no actual behavior behind the scenes. Instead, we have policies enforced by just some rules that we check. So if anyone's used things like, anyone here use style cop? The thing that slows down your compiler a lot? Or is that fxcop? I get them confused. Those are again one of those tools that have a love-hate relationship, usually a hate-hate, because there's some tech lead that wants to check all the buttons and enforce all these crazy rules, and it just makes everyone super angry. Like, oh, you put 2 spaces instead of 1 space, rejected from your reject that one. So I try to balance developer productivity and annoyance versus things that are actually important. So you don't want to go too crazy here, but we can use things like automated tests to enforce that. So one example we had was we would secure every single controller action in our system via an authorized attribute on that controller action. But it was, again, one of those things that I could forget to do. So how do I make sure that I don't forget to put that permission on every single controller action in the system? Well, I guess we could use code reviews, right? Everyone gathered in a room and point out how bad everyone's code is, and everyone feels they hate everyone afterwards. Or you can use pull requests as your means of code review, or you can use pair programming to make sure those things are enforced. But again, those are all human-based ways of enforcing a policy. And anytime a person is involved in enforcing these things, again, that's something that we could easily forget, even if we have the most complete checklist we have possible. Instead, I can use automated tests to do this. So that's what we wound up doing. We wrote unit tests that would scan our system using the type metadata information from reflection to say, let me look at all the controller actions defined in my system. And if any one of those does not have that correct attribute on it, then throw an exception, fail the test, and tell the developer you forgot one. Now, there are always exceptions to this, so we may have a list of controller actions that didn't need it, like maybe the login page didn't need a controller, didn't need that secured attribute there with a specific permission. But that was a kind of a one-off thing. For the most part, though, we want to be able to say, if you forget to do something, I'll have a failed test that just blows up in your face. And so we do this for a lot of things in our system. Things like type naming conventions. So making sure that our view models were named controller, action, and then like model. We would actually have a unit test that ran that said, make sure that if I call something by this name, that there's a corresponding controller action with that same name. Again, that's when, as a developer, I'm creating a new class. I don't have to make a decision about what that class name should be. It's not that instead I have a policy that says this is what your naming convention should be. Visibility rules as well to say what things should be private versus public. Organization, we settled on feature folders, so making sure that we organize things not by kind, but by the thing that the user was doing. We'd build tests around that to make sure that we were following those conventions going forward. Now, of course, I guess someone could disable those tests, but that's kind of a jerk move. Those are things I could look for in a pull request. I'm like, oh, that naming convention test failed, and you just commented out that test? Okay, don't do that, please. But for the most part, our developers were good enough to be able to handle these sort of things. On the other side of this, I have explicit conventions. These are ones where my conventions are not only define a policy, but the policy is actually enforced by how that set of code runs and what actually outputs on the other side. And so as part of this, we'll have opinionated rules about how things should be done. And if we need to have some things that changed, then we can customize those. So for example, it should be easy for a developer to replace this set of code that does manual mapping of stuff with something that automatically maps. And it should be very obvious to them the rules that are in place there. So that was one of our first rules of these conventions, is that policies should be very obvious. It should be enforcing a policy I'm already doing by copying and pasting code, but it shouldn't be this magic policy that everything kind of wires up by itself. I don't as a developer, opt into that myself. So that's why we had opt-in behaviors for AutoMapper. You actually had to tell it that you want to map these two things together. And once you told it, then it would enforce the policy. But if you don't want to enforce this policy, you wouldn't tell the tool that you wanted to do this. Our second big rule is that policies not driving behavior should be testable. So things like the property names need to be matched up. Well, that can be a little bit difficult to make sure that everything lines up properly. So we said, okay, what happens if you spell something wrong on the destination side. So we said that, okay, if you're building this view model that is a special view model just for this view, then I assume that you're going to want to map all those different things. And if you don't want to map it, you have to tell me that you don't want to map it. So we as in me, made a very short little one-liner that says, assert configuration is valid. And what that'll do is run through all your mappings and say, make sure that everything is on the destination side has some kind of mapping associated with it. And if it doesn't, then it's going to throw an exception in your unit test and say, oops, you didn't map this thing, you need to go fix this. And again, this is trying to help that because this is all behind the scenes, I need to have some way to make sure that everything's going to be executed properly, and a unit test is a way we'll do this. Our final rule was that policies need to be debuggable. I should be able to get at the configuration and print it out and say, what is all these things that are getting wired up automatically? What is actually the configuration behind the scenes? And so tools that do a lot of auto wiring of stuff will have ability to just print out all of the configuration associated with it, so that one what do I have line at the end actually returns a string, and it prints out all the different configuration values that you have associated. So if you need to debug something, you can go look to see, well, what's actually all the configuration I have here today. So I want to look at a real-world example of us doing this with not just some behind-the-scenes mapping tool, but something that was actually driving end-user value. For things like DTOs, those were things that the developers were arguing about. But we also found that that kind of arguing and bike shedding actually leaked all the way out to the product owners. Does anyone here have had product owners that argue about like what date picker to use? Just me? Oh gosh. I must have bad product owners, I guess. So they will argue things like, for this page, I want the date picker the little date icon to be on the right. And then some other product owner comes in and says, I don't like the way that page was done. Can we put the date picker on the bottom? Or stupid things like labels being on top versus the side. Every single page in the application was its own special snowflake designed just for that one product owner's whim on that one given day. And so what we want to do is say, right, you as product owners are spending way too much time arguing about stupid stuff on the HTML. What we're going to do is build out a style guide that says this is how our entire application needs to look, and enforce that convention when we actually build the system. I run into this sometime with like UX designers that feel like every single page needs to be its own special way of building things. And there's no consistency across the given application because every single page is completely custom built to whatever that UX person wanted to do that day. So we looked at the code behind the scenes for the templates we were using. And we saw the same kind of thing, this sort of boring, dumb, repetitive code that we'd copy and paste over and over again. Anyone here using Bootstrap? Everyone should raise their hand because everyone's using Bootstrap, right? It's what you do. And Bootstrap kind of encourages kind of copy-paste junk where you have the same div, form group, tags, all that sort of stuff is just the same for every single element you want to show on the screen. And this kind of stuff I just get super annoyed about. Like I have to copy and paste this over and over again and have to make sure I do the right one over and over again because if I get it wrong, then I have a new bad standard going forward. This is one of those cases too that I always had to go to the last page that was created to say what was the last right way of building a page, and hopefully that wasn't anything special, and have to do it on that page as well. So we wanted to not do this. We didn't want to have all this copy-paste junk of labels go on top, filed by the editor, and the validation message goes over here, and then copy-paste again for 20 fields on the screen times 400 different pages, and then I've got this junk copy-pasted everywhere. We wanted to enforce how those elements would look across the entire application. Now, unfortunately, there's nothing really good in MVC or MVC core to help you with this. So we looked at a couple different things. In this one, we looked at templated helpers, and in MVC core, we also looked at tag helpers. And neither of those provided a great way for you to compose HTML together. They're almost entirely string-based. And in my systems, I try not to have as much string concatenation as possible. That's the thing that can get really wrong. And it wasn't easy for us to build more complex things together. The other thing we found is neither of these were, they're either way too much code or way too much like you have to get it just right code. If anyone here has tried to build a templated helper or tag helper, there's a lot of code you have to get like just right for it to work properly. So we said, right, the built-in primitives don't really work. So what we wound up going with was an open source library called HTML tags to enforce conventions about how HTML needs to be rendered. Now, what's different about HTML tags and other libraries we've used is HTML tags actually uses the same metadata system that the other helpers use in order to build out HTML that is tailor-made for every single kind of property in your system. So how does it work? Well, it starts out with, I want to request an element to be shown on the screen. So I say, I want to request an input element or an output element. That request gathers up all of the metadata information it can find, like what's the property name? What is the property type of that one? Are there any attributes or annotations defined on that individual property? It gathers all that kind of metadata information together and passes it through a set of policies that say, based on this metadata information, how should I build the final HTML? This gets pushed out to a tag model, and this is one of the other differences between HTML tag helpers and MVC core, and the other stuff in old MVC as well. This is an object model as opposed to a series of strings that you have to concatenate together. So I can more easily manipulate an object versus dealing with string junk. The final step is, of course, I have to put a string on a page. So yes, there is that final string. And so the goal for us was to say, so these two things, what they really represent is I want to output a form block of HTML for a title property and a form block of code for, what is the other one? Credits property. And I don't want to have to tell the exact HTML every single time. For the most part, it doesn't really change. What I really want to do is make it look something like this. That just says, what's the title form block? What's the credits form block? What's the department form block? And then enforce how that should be built up behind the scenes. So the tooling we used for this included Razor views. We still wanted to keep those, the normal templating engine of the MVC framework we were using. Then our HTML tag library for the tag model, so the tag model objects. And the HTML tag library also has tag conventions that say, if you have a property that has this metadata, build it using these individual rules. So in this library, you basically start out with a blank slate that says, I have some different kinds of tags you can build, and you tell it, when you request that kind of element, what it should do. And it's all through this Fluent interface. So we can start out with some baselines like editors. Always add that stupid form control class from Bootstrap. Now, Bootstrap is not semantic HTML in that you always have to tell it, like, yes, it's an input element, but it's a form control element. Why don't you know it's a form control element? Because it's an input tag. I don't know why, but you always have to tell it what these different things are. The labels always have that stupid control label class. So I'd say, when I request to build a label, always add that control label class whenever someone requests this. We wanted to have some sensible defaults, like, okay, the property name. If I request a label for a property, it should always be that string. If I want to opt out of that through an annotation or attribute, then use that value instead, as opposed to the actual property name. And for things like start date, right? It's a camel case, Pascal case, whatever it is. So whenever I request a property that has this naming convention of camel Pascal case, then can you just split the property names and put a space in between every single capital letter? Because I would always want to do that. I never want to jam these things together. And so the HTML tag library lets us do this. It says, okay, labels, when you see this display attribute, then go ahead and modify it and change the text to the attribute value name that comes out of that attribute. Defining this rule once means that for the entire rest of my application, if I request a label, I only need to put that display attribute on for it to enforce this rule. Even stupider things like every Boolean should be a checkbox. Obviously, like why would I have a Boolean defined in my model that is not a checkbox? Boolean represents a true or false value, just two states. And so a checkbox corresponds to that. Before, I would have to explicitly opt in every single time I would show an input to say, oh, by the way, this property is a Boolean, so I have to remember to say, do a checkbox, not the other thing. Instead, after I teach the convention that all Booleans should have a type of checkbox, I never have to tell it ever again. I just say, give me an input, and based on it seeing that it's a Boolean, it'll say, ooh, Booleans, those are always checkboxes. We also could build new primitives in our system, like display labels. Display labels are slightly different than input or editor labels. Editor labels are an actual label element, and they're tied to the input element. But display labels on the screen are slightly different. They're not built with the same HTML. So we can tell it this new way of doing things. It said, you know what, actually for display labels, we don't want to put a tag in there. It's just the raw text itself. And when you spit out the text, use the property name and break that property name up based on the camel case. So when I build display labels, I can say always display them, always build them by this default display label builder. And if you have that same display attribute we had for the other labels, also modify that for that as well. So now that we built the kind of fundamental building blocks of editors, labels, input elements, output elements, editor labels, and display labels, we can now start to tackle this more complex set of HTML that's being built out. We saw that about 90% of our HTML for inputs looked basically like this. I had an outer div that was a div class form group. Then there was the label based on the property. And then there's another inner div with this medium column 10, whatever that is. I'm sure it means something in Bootstrap. I just copy and paste that thing over and over again. And then finally, I have the actual inputs and validator sections I have on here. Now, if I'm copying and pasting this over and over and over again, what I'd like to do is say, can I just establish a primitive that says build a form block for all these pieces? And just do that instead, as opposed to copying and pasting the same stupid code over and over again? Now, if I was using just raw ASP.NET MVC or MVC core, what are the things I can use to try to do that? I've got partials. Partials are good for HTML-focused elements, but partials are really bad for passing model information down. So that's not a really good fit for this one. I could build another HTML helper extension that returns a string, but that's not that great because I'm mixing in these different like HTML tag way of doing things plus raw HTML, and they don't really mix together. I have to do more string concatenation, and I want to try to avoid that as much as possible. There are custom tag helpers in MVC core, but those are complicated to build. You have to make a new class for every single one you do of those, so that's, again, more complicated. But what I could do is then, instead of trying to mix those MVC concerns that don't all fit with this, I can use, again, that same HTML tags library. In the HTML tag library, because it's object-based, is now really easy for me to build up and mix the convention-based way of building HTML with these other more larger primitives. So in this code, what I'm doing is I'm first building up a div tag via an object as opposed to a string. I say, give me a new div tag, add a CSS class. And if the syntax looks familiar, it's because the developer that built this was heavily inspired by jQuery at the time. So it's this very like fluent syntax that kind of matches what jQuery did. I have that div tag, and now I want to have the label tag. But the label tag, I want to use that same label helper I was using before. So I say, okay, go ahead and give me use the label method to return the fully formed label tag as an object, as opposed to what I had before. And if I need to modify it, I'll have a callback with that label modifier to modify the label tag. Do the same thing with the input that says, give me the input for that property based on the expression, return it back. And then finally, I can append those two tags to my outer div tag. So I have an outer div tag, and then finally those two inner inputs and labels as one set of HTML tag that gets converted to string. So the final form looks more like this than what we had before. I have the normal form blocks that are always the label and input and validation as one single line to say, give me a form block for all these different things. For things that don't have labels, I can drop down into the more basic building blocks, these input ones as well. And if I do want to use the built-in ones from MVC, I can still use those as well. Nothing's forcing me to completely use this entire new library. I can go back and use the other ones as well. So this meant that our developers, that were building systems like this really just built DTOs, map that DTO using AutoMapper, and then here they're just put all these different form blocks on the screen because their screen should be, by and large, very consistent in how they should be laid out. This removed probably 90% of the bike shedding in our systems, where we were arguing over layouts and positions of things and said, nope, let's just enforce a style convention through a tool and then no longer have those conversations with the product owners or the developers how all these different pieces should be put together. But wait, I know you were thinking, okay, this is great, this is using server-side rendering, but no one here is using server-side rendering anymore, right? Everyone here is using Angular. That's what everyone's doing now. So yeah, what about, I'm not using server-side rendering, I'm using some other thing like Durandal Angular React or something like that. And that's when I get sad because I hate those frameworks with a passion. And so we have to go back to the drawing board and say, okay, well that's all well and good for server-side rendering. How can we have that same kind of policy enforcement on the client side? And so I have to go back and look and say, well, how are these things being put together? I kind of have a mix. I have a mix of, this is Angular, I believe, with those little double mustache-looking things over there. And so it has a mix of HTML and these bound elements here. Now, Angular does have a way for you to, in the newer versions, bind directly in HTML, so I can still use the library I had before. But the way these are typically built is whenever you have a request, you make a post to get all the information and returns back, or get, and then returns back all the information back to the browser, including templates and all that sort of stuff. So all the rendering happens on the browser side, but the metadata is over on the server side. So the way we solve this problem in our systems was do that same sort of conventional base building of HTML. And what we do is we'd actually pass those templates of whatever single page application thing we were doing through the template parser on the server that had all that complex metadata of the models we had behind the scenes. And only after we went through the template parsing, those were the final templates we actually passed to the front end single page applications that would then bind those data objects to the screen. This was complicated, so I would only really do this if I was able to enforce those kind of conventions on both sides. A lot of times when I have more complicated behavior on the client side, there is no like one way of laying things out. It's more a lot more complicated client-side behavior. So I would only attempt this only if I can look at several screens and say, ooh, it looks like we have a lot of copying and pasting going on, and not only copying and pasting of code, but copying and pasting of concepts. So let's go ahead and pull those out into something that can enforce those concepts via policies. So, some parting thoughts. Conventions are good. They're okay to use. Magic in these systems is bad. So if you find yourself having too much magic or too much explicit configuration, don't use the tool. But absolutely do not use code generation. Code generation will not enforce these kind of policies for you. It's just a broken system and won't give you to this nice, happy place of enforcing a coding policy going forward. So that was blowing up the bike shed with conventions. If you want to see a running example of this, you can go to my github.com/jbogard. I have a set of sample projects for both ASP.NET MVC regular MVC. I have a sample for ASP.NET Core, and also ASP.NET Core on .NET Core. Just search for, you'll see them. They're all pinned repositories there. So go check them out if you want to see a running example of these. Otherwise, I'll have time for questions. And thank you very much. So questions? Yes? I totally made that up, by the way. Yes, I said 90%, but I've just believe me, trust me. So essentially the question was, what's the learning curve on using these kind of tools? I'd say for our teams, we do make that part of the onboarding process. It's not just blindly use these tools and good luck with it. We do teach them like the concepts behind it to say, this is the reasoning behind how we build these systems. So we actually have like an onboarding process that's like a week that's taking through a lot of these concepts to say, we arrived at this final point, but we want to take you on the same journey we went through to get to this point so that you understand why we do the things we do and not just say, here's a bunch of things and don't understand why we put all these things together. It's really important for us to communicate the why behind these things too. So I would say, it get rid of 90% of the arguments on that project, but on the next project, we reevaluate all those decisions again about what are the policies we actually need to enforce on this individual one. This project as well, I waited for probably 2 or 3 months to have enough features built up to say, let me take a step back. What are we actually doing here? Have enough examples to work with, and then use those as the basis of a policy to enforce going forward. And it's not necessarily something I just, from the starting gate, saying, let's use all these libraries and enforce all these rules, and maybe the rules don't actually make sense. I still want to evaluate whether those rules actually make sense for any given project. You said there's a part 2? Okay, so those 2 parts. Learning curve, okay. All right, well, thank you very much. If you want to talk to me afterwards with more questions, I'll be hanging out here, or maybe at the beer place over there, but I'll be around. Thank you very much.